The MACD strategy that I will be implementing today might seem easy or difficult to you depending on your level of expertise with time series data and coding. I will try to explain these concepts as simply as possible and can assure you that by the end of the video, you will start to get the hang of these concepts. Due to the simplicity of the strategy, it is probably best to not deploy it into the market, but that doesn't mean you shouldn't learn it. The analogy that I like to use is that of progressive overload. So, when a new person goes to a gym, they do not try to immediately bench press 100 kgs. They first start with a weight that they're comfortable with. And it could be anything, it could be 20 kgs, it could be 5, it could even be 3 kgs. But it is very crucial to start with a weight that you are comfortable with and you work your way up to your goal. And that is exactly what this channel is all about. I too am quite new into this field, but I am slowly grinding the basics and I'm slowly working my way up to being a quant developer. Now, without further ado, let's get on to the video. As you all know, we are going to be implementing an MACD crossover trading strategy in Python. I have provided the code for this Jupyter notebook using a Google Colab file, and it is in the description below. So if you want to code along with me, you can just press the link and get started. The process that I'm going to be following is importing the libraries and data. That is very simple. Calculating the daily returns. Then we generate the strategy signal, and using that signal we decide if we want to buy or sell. We are going to be doing a long and short strategy. You can convert this to a long and sell strategy very easily, and I can show you how to do that. Then we will just calculate the strategy returns and evaluate the strategy. Before we begin, let's just understand what the MACD strategy actually does. If you're familiar with simple moving average, then this just calculates the exponential instead of the normal sum. You do not want to get too invested into how this works yet if you're not familiar with finance strategies, because that will just confuse you. Take the strategy for what it is right now and do not try to break down the intricacies of why this works. You will soon begin to develop that intuition the more you use these kind of strategies. So we calculate the 26-day moving average, we calculate the 12-day moving average, we subtract the 26-day moving average from the 12-day, and the signal line is the 9-period EMA of this line. Usually people use this setting where it's 26, 12 and then 9. But you can of course change that depending on your strategy. Just make sure that you have these libraries installed. If you're doing the work in the Google Colab link, then you can just press Shift Enter and it will download immediately. Let's begin by importing the libraries. Whenever you want to execute these cells, press Shift and Enter. Then we want to import financial data. It is best to import this data using an external source, but since we are all just beginners, let's just use Yahoo Finance. Choose any ticker that you want. I will just choose Apple because everyone knows what this is. Then we will create this function called import data. This function will take the ticker symbol that we want. The default value will be Apple. Then we will have a start and end date. And I'm just going to set the default values for these as well. If you do not know what the default values actually do, basically if you do not provide this variable when you're creating the function, then the default value will just be start date as 2020 and end date as 2024. Okay, this is a very simple function. If you do not understand this, just refer to my Yahoo Finance video that I created. Start equals start do not forget to return the data. I've actually spent countless hours figuring out why my data is not downloading and I just did not return it. Let's move on to calculating daily returns. The variable that we'll take is just going to be data. Oh, by the way, if you want to see if this data has been downloaded, you can just do data.head. And I'm not going to put anything because I'm lazy. Let's do df.head. Now we can calculate the daily returns. The only input variable that we take is the data set. We can use R actually. I will use log returns just as a personal preference to calculating the daily returns. This drops all the null values. And then we can just return the data. If you're confused on what this does and why it does it, I could go and I could explain it to you in an Excel file. What we're trying to do is calculate the daily returns. So maybe this is our stock data. It goes from 100, 101. Maybe it drops down to 99 and goes back to 101. Oh, my bad. And it returns back to, maybe it goes up to 103. So this is the stock data for like 5 days. And we want to calculate the daily returns. What this will do is, when we do shift, when we do data close by data close.shift, internally what's happening is this data is being subtracted with this data. We basically shifted this data down by 1. Let's include this as well. And this is exactly why we had to drop NA, because these two will be null values and we do not want to incorporate that into a data set. And we're just losing 2 values out of like 1,000 rows. And when we do np.log, what this will do is log of this by this. And see, this is the null value. So when we do drop NA, this gets automatically removed. But these are our daily log returns. If you had trouble visualizing it, I'm hoping this helped you. Why do we use this? It's because we want a benchmark for our strategy. How does this serve as a benchmark? Basically, if you were to buy and hold a stock and not sell it at all from the start of the strategy to the end, then you would calculate your returns using this metric. So what we're trying to say is that we want to see if a strategy is better than just buying and holding a stock, which is something so simple. That is what we want a benchmark to be. Let's test this out. So df equal to calc / daily returns. Oh, I did not run this. Let's run this and we can see we have the daily returns column. Perfect. Awesome. Now let's move on to actually computing the signals. We have the data as the input variable. We have EMA1, which was which you can set as default as 12. EMA2, we can set the default as 26, and EMA3, we can set the default as 9. We discussed this at the start of the video. Now we do is EMA1, data close, use the close price of the stock, calculate the exponential moving average. This is why I love Python, because you can just type this. When I used to code these strategies in Excel, it used to be such a pain, but you can just do it in one click and you know it just works. EMA1, adjust. Do not worry about this. Do not worry about these small details just now. And then you calculate the mean. Understand why I'm doing it. Do not try to go into the depths, because it is going to confuse you if you're just a beginner. Now we do MACD. We compute the MACD column, data EMA1. Oh, my bad. EMA2 minus data EMA1. So as we discussed, it was 26 minus 12. Computing the signal in the end. Let's just drop the NA values for good practice. Even if there are no NA values, then nothing happens, so it's just better to do it. Perfect. Now let's test it. So we have the df variable to compute signals. Keep everything as default and compute it. Let's see, df.head. Perfect. We have the EMA1, we have EMA2, we have the MACD is going to be the same on the first day, of course, and we have the signal. Now we're almost done. We can just calculate the strategy returns. I'm just going to copy paste this because this is pretty simple stuff. All you do is make this new column strategy returns, and you multiply the daily returns with the position you're in. So if the position is 1, then it's basically you buying it and you're gaining this much profit, and if you shorting it, then it's just minus that, drop NA in plus equal to true, and we can do df is equal to and we have this entire column of strategy returns for each day. Now there's two ways you can go about evaluating the strategy. One is the lazy way and one is the hard way. Today I'm going to use the lazy way. So all you do is use this function from Python. We did import this earlier, if you remember. We imported Quant stats. What Quant stat does is it does everything you need to know when you're evaluating the strategy. We'll do this and then run it. Df equal to assessment. You get all the performance metrics that you need. You can see the strategy is really bad. Sharp ratio sucks. You can see this is the cumulative returns, it's going down and down. So basically you do not want to trade this. But the reason why we are learning to do even the bad strategies, or why I'm teaching you these strategies, is that you need to start from the bottom. And this is what I learned, so I'm just trying to explain to you what I learned. But also, I probably would not teach you the strategies that actually gain profit, because that is something that you need to do on your own. And if you're confused on, if you're thinking, how do I make my own strategy? Then you can check out my other video on where I go over the steps that you need to take before you make your strategy, and then you can start developing it. So that video will actually provide you a really good starting point on making your own strategy. What I did here was an object-oriented approach. I put everything that I quoted above inside a single class, and you do that because you actually want to optimize all the parameters, because maybe the strategy is good but using 12, 16 and 9 is actually not that optimal. So we have all these different range of values that we're going to just test. I'm not going to go over how I wrote this, you can check it out later, but you can see I go over each strategy, and maybe the first one is 10, 24, 8. You can see this sharp ratio, you can see the drawdown, you can see the win rate, and in the end you just get the best strategy out of all these. So it's still running because it's a pretty big file. The best strategy was EMA 13, 28 and 8. Sharp ratio still quite low, you do not want to trade this, but better than the first one at least. You gained a 51% profit in 4 years, which is also quite low. Well, that is it for this video. If you enjoyed it, please leave a comment below. I'm still trying to understand how to teach these strategies, so if you found something that you did not understand, definitely let me know in the comments below. Peace.